Welcome everyone to this Institution of Environmental Sciences webinar, The Role of EIAs in Promoting Healthy Soils. This webinar is being held in collaboration with the British Society of Soil Science. Before we kick off with the webinar, I just wanted to make you aware of a few things. Number one is an upcoming IES event which may be of interest. This is the Land Condition Symposium, which is a hybrid conference being held on the 16th of November. This one-day technical symposium is returning this year to provide professionals with an opportunity to debate, discuss, and address topical issues at the centre of land condition. And this year it's centred around the theme of soils. I'll put a link in the chat box in a minute for anyone that's interested. I'll quickly now hand over to Sarah Gary, Executive Officer at the British Society of Soil Science, to say a few words from her end. Thanks, Sarah.
Thanks so much, Ethne. And on behalf of the British Society of Soil Science, we're absolutely delighted to be co-hosting this event with the IES today. As Ethne mentioned, my name's Sarah and I'm the Executive Officer of the Society. The Society will be 75 years old next year, and we're an established international membership organisation and charity committed to the study of soil in its widest aspects. We bring together those working within academia, practitioners implementing soil science in industry, and all those working with or with an interest in soils. Anyone with an interest in soil is welcome to become a member, attend our conferences and webinars, receive complimentary access to our 2 scientific journals, and a host of other benefits. Next year, the British Society of Soil Science will be hosting the World Congress of Soil Science in Glasgow from the 31st of July to the 5th of August. The Congress is the leading international soil science conference. It's held every 4 years in different countries and usually attended by around 3,000 soil scientists from around the world. It welcomes anyone with an interest in soil science to meet and discuss the critical global issues relating to soil. The theme for the next Congress is Soil Science, Crossing Boundaries, Changing Society, and we'll focus on that link between soil and society, with sessions covering soil systems, processes, soil management, and how we interact with and use soils around the world. We are now welcoming abstract submissions with a deadline of the end of this month, and the portal is available at all the W's 22wcss.org. So if you are interested in submitting an abstract, please do that as soon as possible. And finally, we hope to welcome you to Glasgow for the conference. And I'd just like to end by thanking Ethne so much for inviting us along today. And we hope you enjoy this presentation.
Amazing. Thank you so much, Sarah. Great. So we'll get on to the webinar now. We are absolutely delighted to be joined by 2 expert speakers who will be exploring the importance of healthy soils, why they should be included in EIAs, how they are currently covered, and how EIA professionals can be supported to cover them. After their presentations, you'll have the chance to ask our speakers some questions. So please do submit these in the Q&A option at the bottom of your screen at any point during the presentation. If your question is directed at a particular person, please put their name in that so I know that. You will also have the opportunity to raise your hand if you'd like to ask your question in person, and that will be during the Q&A session at the end. So thank you so much for logging in. It's great to see so many of you here. And I'll now introduce our first speaker. So Eleanor Reid is a Chartered Senior Specialist in Soils at Natural England, contributing to enabling Natural England's statutory consultee role in assessing development proposals on agricultural land and soils, ensuring soil protection and management are embedded in land use planning consultations. She also provides advice on various soil health issues, including the Sustainable Farming Incentive Scheme. Prior to Natural England, Eleanor worked with an environmental consultancy, providing peat, soils and agricultural advice, and specialising in the delivery of large-scale infrastructure projects, including HS2. The work included undertaking soil and peat surveys for agricultural land classification, forestry and other purposes, preparing soil management and restoration plans, and the preparation of EIAs for UK and overseas developments. Thanks so much for joining us, Eleanor, and over to you.
Well, thank you very much for that introduction. I'll just share my screen. The incoming chair for the Professional Practice Committee at the British Society of Soil Science. So we are currently facing the combined challenges of climate change, biodiversity loss, and ensuring food security. Recently, we've seen that healthy soils are increasingly being linked with providing nature-based solutions and contributing to achieving net zero. The fact that soils have the capacity to contribute to tackling these crises highlights just how important it is that our soils are healthy and that we consider this important resource carefully for sustainable development. So I think I've been given the easy task today of talking about the importance of healthy soils and why they should be included in EIA. And I think to start off with, I am just going to show you why I think they should be healthy. So soils are our most important natural assets. They underpin all terrestrial life. They deliver terrestrial ecosystem services and influence the distribution, diversity and ecology of habitats and species. They support the food we eat. They control flooding, influence water quality and quantity, and represent our largest land store of organic carbon. And these can be considered the soil's ecosystem services. And their fundamental importance has been recognised in many recent policy drivers, including by the Natural Capital Committee and the government's 25-year environment plan, which includes the key targets for sustainable soil management by 2030 and for peatland restoration. But what does a healthy soil look like? Healthy soils support healthy habitats, be that beautiful landscapes, practical social spaces, productive agricultural land, or practical suds. And what is key is to understand the variability of soils. So different soils will be able to support the various landscapes and habitats shown on this slide. And as a result, we'll be delivering a range of different ecosystem services to different degrees. Unhealthy soils, on the other hand, those that have been damaged, degraded, compacted, mixed, unsustainably managed or used for the wrong purpose, not only impairs the delivery of ecosystem services that healthy soils are so good at delivering, but they can also damage the environment. So these negative impacts can increase the sediment, nutrient and chemical load entering our water courses, so impacting water quality. They can increase the risk of flooding, reduce the amount of carbon held within the soils, and just become a substrate that's not very suitable for plant and crop growth. So generally when soils are healthy, we don't really notice, but when soils are unhealthy, we definitely notice. It's hard not to notice the flooding and the erosion, failed planting, delays to construction programs and remediation costs. It's also the main difference between these two slides. So when soils are degraded and damaged, we generally can see the soil and the soil itself is treated as a problem, so a pollutant and the reason for other environmental complaints. Whereas soil, I think historically, has not often been recognised for supporting healthy, thriving habitats and landscapes. But I think this is actually changing with a growing awareness of the importance of soils amongst planners, developers, construction workers, ecologists, and so on. So what is a healthy soil? Good soil health can deliver the ecosystem services I've just mentioned. However, equally, soils are highly variable and have different capabilities. For example, take this upland habitat supported by a mix of peat soils and organomineral soils. A healthy peat soil would be expected to be supporting a healthy cover of peat forming vegetation, which would be promoting the continued sequestration of carbon. So traditionally, your sphagnum mosses are growing and they're supported by the peat and they're pulling down carbon dioxide from the atmosphere into the plant material, which itself is sort of building this peat. So it's creating a really good store of carbon. It's also acting as a giant sponge, slowing the flow of water off the hill slope, which is resulting in a natural flood mitigation. And the peat itself is supporting loads of rare species of flora and fauna. This acidic, nutrient-poor soil, however, is not so great at supporting productive agricultural land. So it's knowing what the soils are good at doing. On the other hand, unhealthy peats can occur where we have degraded the peatlands, often by draining or overgrazing, and that's resulting in the oxidation of carbon in the peat. So the peatlands are no longer acting as a store for carbon, but they're actually putting that carbon back up into the atmosphere and doing the opposite of what we want it to do. And that in turn is then changing the type of vegetation that degraded peat can support, which is further reducing that amount of carbon that's been sort of laid down in the litter. So it's a really bad cycle. So that's a good sort of comparison of what a healthy peatland is and an unhealthy, drawing primarily on the carbon sequestration capability. Alternatively, you could take this agricultural habitat supported by deep, well-drained, nutrient-rich, loamy soils. So a healthy agricultural soil would be expected to be good at contributing sufficient quantities of nutrients and water to support good crop growth, allowing a good number of workable days where the farmer can get on the land without causing damage. Although, of course, that does reflect the inherent soil texture as well as manageable properties. So you have to take that into consideration also. So this is aided through good soil structure, and good soil structure is key here. It promotes good aeration and water movement through the soil profile. And it's developed naturally over time through primarily the combined action of soil microbiology and soil organic matter. And these are the two sort of key properties that I'll keep referring back to whilst I'm talking. An easy way to create an unhealthy soil is to compress it. So basically compacting the soil, where you completely damage that soil structure, losing the interconnected pores, resulting in poor aeration, impermeable soil horizons, saturated zones, creating a really stressed environment for the crop to grow in. And this can occur as a result of heavy vehicles trafficking over the soil, and is exacerbated when soils are wet, particularly clay soils, or when organic matter levels are low. And this can occur as a result of agricultural activities or construction activities, so when there's heavy kit on the land. So low soil organic matter levels is of great concern when it comes to soil health. The decline of soil organic matter, either through repeated soil cultivation or, as I mentioned previously, with the draining of the peats, can increase oxidation rates, putting carbon dioxide back into the atmosphere and other greenhouse gases. But it can also be reduced from limiting the amount of organic matter you're putting back into the soil, for example, through crop residues. So this is reducing soil's resilience and delivery of the ecosystem services, including that all-important storage of carbon in the soil. So the biomass supporting soil function can be reflected in the agricultural land classification system. This is a system used in England and Wales, and it looks at the soil, the site, and the climate characteristics of an area to determine the agricultural versatility and capability of the land, and ensures scarce, high quality land can be protected from loss to development through the planning system. And Scotland has a similar system, the Lands Capability for Agriculture. So the ALC system comprises 6 grades, grades 1 through 5, with 3 subdivided into 3A and 3B. In planning, grades 1, 2 and 3A are termed the best and most versatile agricultural land. Current planning policy for England, the National Planning Policy Framework, currently states that the planning system should protect and enhance soils and prevent development from contributing to unacceptable levels of soil pollution. Local planning authorities must assess the economic and other benefits of the best and most versatile agricultural land. Poorer quality land should be used in preference to that of higher quality, and the reuse of brownfield sites is encouraged. Again, the Scottish planning policy protects against protects their prime quality agricultural land, which is classed 1, 2 and 3.1 in their LCA system. And they also look at protecting other valuable resources like peat soil. So if you remember the slide of the upland in the background, there was the wind farm. So consideration in the environmental impact would have been needed to look at the peat soils, looking at the carbon balance, and also looking at peat slide risk assessment. But on these agricultural soils, these deep, well-drained, loamy soils, coupled with the local climate data and site characteristics, indicate that this particular site is BMV. However, these soils, when in a healthy condition, are not only contributing to crop growth and food security, but also a myriad of other ecosystem services, including flood risk alleviation. But it's really important here to note that it's the healthy soil that's really important. They need to be managed in such a way to maintain or increase the soil organic matter content, to avoid compaction and increase the soil's resilience to deliver that range of ecosystem services. So this is Hannah's Meadow in the North Pennines AONB. This is a species-rich, unimproved upland hay meadow and grazing pasture, and it's evolved as a result of traditional farming practices over many centuries, avoiding fertilizer input and the need to reseed. And they host such a range of wildlife that they have been designated a SSSI. This agricultural habitat is supported by slowly permeable, seasonal waterlogged soils and are mapped as ALC grade 4, so are termed non-best and most versatile. However, with the long-term low inputs and minimal soil disturbance, these well-structured agricultural soils support a vastly biodiverse habitat both above and below ground. And that below ground biodiversity, known as soil biodiversity, is really important. So whilst ALC is a great tool for classifying the capacity of soil in combination with the site and climate properties to contribute to biomass production and thus food security, it doesn't necessarily reflect a soil's capacity to support biodiversity, be that above and below, or combat climate change. So as well as our agricultural lands and uplands, our soils support habitat creation, be that in urban or rural settings. So it's also really important to remember our urban soils. They also support woodland planting and the development of open space, including private gardens, public parks, playgrounds, sports fields, etc. All of which need different things from the soil. And equally, there are soils which are more suited to delivery of these land uses than others. And this is really key for sustainable development. A good understanding of soil is key to making optimal choices about sustainable use and management of soils. And this is why they need to be considered in EIAs, as well as the consideration of ALC. So development is essential, be that housing, roads, energy, commercial development. And it typically involves a change in land use and often requires a degree of land sealing, which can result in the permanent loss of soil function at that location. Soils are often excavated and taken off site and often end up in landfill, which is the absolute worst case scenario for soils, as they are a finite resource. Where land is not sealed, the soils are typically disturbed to facilitate construction, which can also result, in a worst case scenario, in the permanent loss of soil functions through inappropriate development or poor soil handling. And typical impacts on the soil resource as a result of construction activities can include the sealing of the soils with impermeable materials, which prevents drainage and damages the soil structure, compaction through the use of heavy machinery, reducing soil quality, for example, through soil mixing, mixing topsoil and subsoil, or mixing with contaminated material, and the total loss of the soil resource. So this schematic on the screen is from the Viking Link interconnector, which is currently undergoing construction, where they're laying cables. So this particular type of construction is a temporary land take, where there'll be the temporary stripping of soils and stockpiling while they lay the cable before the soils are replaced and restored. So in this particular scenario, it's really important that the different soil types are stripped and stockpiled separately, that they're stripped and handled when in a suitable condition, so when they're sufficiently dry, and that they're restored where they were stripped from, so that the resulting soil profile is what it was before any construction happens, and that when it's handed back to the landowner, they're getting back what they sort of gave in the first place. So the land is the same agricultural land quality, and the soil can continue to provide the ecosystem services it did in the first instance. Alternatively, you can have permanent land take. So if we pretend that that running strip in the centre of the schematic is going to be for a permanent road, that would require permanent land take, and those soils that were stripped from that area would not be able to be replaced in that same sort of location. So consideration would need to be had for where those soils could be reused sustainably. So they're not taken off site and put to landfill, but they are reused somewhere. But to be able to do that, we need to know what's on site. We need to understand the soil characteristics so they can be appropriately managed, and that appropriate mitigation can be put in place and sustainably managed, which is one of the objectives of the 25-year environment plan. So we need competent, trained soil surveyors to be able to survey the land, identify the soil characteristics, how they change across a site, recognise the different soil types and what the different types may be best appropriate for, and communicate that to the developer or the EIA team. So the soils may be heavy, so really clayey, hard to handle and difficult to reuse in landscaping. So the structure of a clay soil tends to be less resilient than a sandy soil, and so when it's handled can result in damage to the soil structure, particularly if it's handled in incorrect conditions. So when it's restored, it can often be prone to waterlogging, which is not great for landscaping, but could be ideal for reuse in pond creation. Other soils, so loamy and sandy soils, as I mentioned, are a little bit more resilient to handling, and so could be better placed for use in landscaping. It's also important to consider soil pH changes, so you can have acidic or alkaline soils. They can also have different nutrient statuses, so soils from agricultural land could be high in nutrients, but also potentially high in weed burden, whereas other soils could be low in nutrients and potentially more well suited for use in species-rich habitats. So if the soil resource isn't properly assessed, there's a high probability that targeted landscaping and habitat creation will fail, alongside the lack of delivery of the soil ecosystem services. So we need to start with the soils. We need to use the soils to inform what they'll be able to support most effectively, and use the soils to inform the handling methodologies necessary to minimise damage to the soil during construction. Identifying the most appropriate end use of the soil is only part of the solution though. For if that soil is damaged at any point as a result of construction activities, the soils will be less able to deliver its ecosystem services and successfully support the proposed habitat or land use. Inappropriate use and management of soil resources is often responsible for costly programme delays, the failure of planting schemes and the higher incidence of surface runoff. And this can mean non-compliance with planning conditions. In addition, where development involves a large amount of sealing, there is limited opportunity for the reuse of soils on site. So the early consideration of potential surplus soils in the planning process can provide opportunities to conserve them and increase the sustainable use of soil resources. However, it's important to note that this could require larger red line boundaries to accommodate this soil resource. So again, this early consideration of the soil is just so important. There are a couple of guidance notes that set out mitigation measures to minimise the impact of construction activities on the soil, including the DEFRA Construction Code of Practice for the Sustainable Use of Soils on Construction Sites, and the recently revised Good Practice Guide for Handling Soils, which is focused on mineral workings. And these mitigation measures should be considered as part of the EIA mitigation tailored towards the soil types on site and feed into the SEMP or equivalent. The British Society of Soil Science have also published a guidance document benefiting from soil management in development and construction, which also sets out recommendations for the production and implementation of a comprehensive and site-specific soil management plan, which are considered at the design stage of a development. So it's informing that master planning process. Again, relying on a site survey, feeding in site-specific soil information. So hopefully that gave you a bit of an idea of the benefits and the importance of the early consideration of soils in EIA, and I'm happy to answer questions following the talk from Chris. So thank you.
Amazing. Thank you, Eleanor. That was super interesting, really useful presentation. Yes, please do everyone put your questions in the Q&A box, and then we'll get to those at the end of Chris's presentation. I can see that one person's put, could they have the links to the British Society of Soil Science guidance in the IOQ one. So the soils one's been put in there, but if Eleanor, if it's possible for you, oh, it looks like the other one's just gone in. So thank you. Thank you, Richard. Amazing. Okay, so yes, please put your questions in. I'll ask those after Chris's talk. In which case, without further ado, I'd like to introduce our second speaker, Chris Stapleton. Chris is a soil scientist specialising in soil and agricultural land classification surveys. He is also a qualified member of the Royal Town Planning Institute, specialising in managing environmental impact assessments and writing environmental statements. His final full-time role was as HS2 route-wide lead in assessing the effects of the new railway on agriculture and soils, and he is now semi-retired. Thanks so much for joining, Chris. Over to you, and I'll share my slides.
Well, good afternoon, everybody. I hope that you can hear me loud and clear, and also hello to some of the people out there who know me. Before I begin, perhaps I should provide some context to my presentation. I have spent my career using soil information within the planning system, and 2 years ago, the Institute of Environmental Management and Assessment, IEMA, asked me to form a working group to produce guidelines for the assessment of development impacts on land and soils within the EIA process. The final draft of those guidelines is now with the Institute, and the guidelines are due to be published soon, but I don't know exactly when. The working group of about 20 people comprises EIA practitioners including highly experienced soil specialists, together with representatives of the UK environmental agencies. The thing is that there are a number of people on the working group who are particularly interested in soil health. And as a consequence of this, the guidelines do contain some of their initial thoughts on the use of the concept of soil health within EIA. And I hope that you find that encouraging. And what I've done is to set out these initial thoughts in the first two of my slides, the first of which is on your screen now. How is soil health currently covered by EIAs? The UK has a wide range of different soil types which function in different ways to support different land uses and habitats. The current emphasis in EIA is on the impacts of development on soil properties that determine soil functions, not soil health. When I say soil functions, I feel sure that most of you know what I mean, but I'm talking about things like biomass production for food, fibers and timber, the role of soils within the hydrological and carbon cycles, the way in which soils form a substrate within wildlife habitats, and soils as a source of materials like sand and gravel. There are others, but I think they're the main ones. Anyway, the natural variability of soils and land uses in the UK introduces complexity in determining what soil health should be defined as. Currently, it has to be said that there are no established baseline standards, baseline soil standards, against which the significance of development impacts on soil health can be assessed within EIA. Next slide, please, Ethne. So in order for soil health to be covered by EIAs, an EIA would have to assess the effects of a proposed development on selected soil properties that define soil health. Then determine whether the impacts can be avoided, mitigated, or compensated for. Members of the working group have suggested the following possible soil health baseline properties, which actually are quite closely linked to soil functions, by the way, including bulk density, structural development and porosity, soil profile drainage, water storage capacity, soil organic carbon, and some measure of soil biodiversity, perhaps in terms of microorganism populations. Other possible properties would be soil pH, levels of nitrogen and phosphorus, but these properties have yet to be established. So that is the second of my two slides on the question of how soil health is currently covered within EIAs. And now with the next slide, Ethne, I want to move on to what was originally my question, which is, how can soil practitioners incorporate soil health into the EIA process? Well, as I've explained, IEMA intends to publish the guidelines on the effects of development on land and soils within the context of EIA. The original focus of EIA has always been on agricultural land quality as described by Eleanor, in terms of the 5-grade agricultural land classification system in England, Wales, and Northern Ireland, I think, together with the land capability for agriculture, the 7-class system used for land use planning purposes in Scotland. again, the original focus of EIA was also on the reinstatement of displaced soil resources on surface mineral sites, although within the last, 10, 15, 20 years, that has been extended to cover most construction sites in the DEFRA guidelines. The emphasis originally was on protecting one soil function, biomass production, food, fibres and timber. The more recent focus is on effects of development on all soil functions. The new IEMA guidelines will build on this approach by filling what are in effect gaps in the existing EIA evaluation methodology. These methodologies are currently used by soil specialists in EIA teams to assess the significance of development impacts on land and soil. And if you want some examples of how this is currently done, look at the published and widely used evaluation methodologies produced within Highways England's Design Manual for Roads and Bridges in sections LA 104 and LA 109 in particular, together with the Institute of Civil Engineers EIA Handbook. These do refer to the effects of development on all soil functions, but there are gaps in these methodologies, and these will be filled by the IEMA guidelines. The gaps do not show how to assess the sensitivity of the land and soil resource to development impacts, or the magnitude and hence significance of the impacts for all soil functions. So at the risk of repeating myself, the new IEMA guidelines will set out a more comprehensive evaluation methodology, which does consider the effects of development on all soil functions for all types of construction. This began when I set out an initial iteration of the proposed methodology in Gaining Ground, which was an article in the IEMA magazine Transform, published in June 2020, and subsequently shown in more detail by IEMA on their website. And I think that that is what actually prompted IEMA to come to me to ask me to form the working group to lead in the production of the new guidelines. When the guidelines are published, IEMA will expect soil specialists in EIA teams to use these new guidelines to assess the significance of development impacts on land and soil. And within the guidelines, effects on selected soil properties and consequent changes in soil functions will be used to determine the significance of development impacts. Next slide, please. Impacts are assessed against soil baseline conditions. The guidelines will actually set out the soil survey methodologies for EIA baseline studies, and the information will be collected during site-specific and detailed soil and ALC/LCA surveys, with results generally being shown on maps at a scale of 1 to 10,000 or larger. These baseline studies will inform the selection of soil properties for the assessment of development impacts and their significance. I would add that predictive models based on reconnaissance level soil databases do not provide adequate information for EIA purposes. In terms of mitigation measures, the survey information collected for the baseline studies also informs the assessment of soil resources within a study area and their conservation for mitigation measures. And Eleanor has touched upon this. This involves the reinstatement of displaced soils and the maintenance of soil functions, both on-site and off-site where possible and appropriate. This can include restoration for agriculture, forestry, habitat creation and translocation, and landscape planting. Final slide, please, Ethne. For EIA, the impacts of development on selected soil properties, physical, chemical, and biological, and consequent changes in soil functions are determined within a development site. These changes in soil functions will then be used in consultation with other specialists in EIA teams, hydrologists, okay, landscape architects as well, to assess the significance of developments on land and soil with reference to the evaluation methodology in the IEMA guidelines. A key point in all of this is that the guidelines are not prescriptive about the selection of the soil properties. Their selection is a matter of professional judgment based on the nature of the proposed development, existing soil functions within the study area, and the sensitivity of the receiving environment within and around the development site. So in answer to the question, the incorporation of soil health into environmental impact assessments and environmental statements, it is a case of defining soil health with reference to soil properties that are affected by development and which also determine changes to soil functions. And this will help to integrate the soil health concept into EIA. So that is my advice on the development of the soil health concept for EIA, and I hope that you have found it helpful. Thank you very much. Back to you now, Ethne.
Amazing. Thank you very much, Chris. That was really interesting and a really comprehensive overview. So thanks very much for that. I'll now move swiftly into the question and answer section, as I can see that we've got quite a lot coming in. So to kick off, let me just go back up to the top. So Eleanor, I might pose this one to you first, and then Chris, if you have some comments on it, please come in as well. So if current soil and environmental science students are interested in a career in soils and EIAs, what advice would you give them?
That's a good one. I think it's with soils becoming increasingly more important, and we're wanting to see them incorporated into more initiatives. We need more trained soil scientists, more trained soil surveyors, and so it's to get that hands-on practical experience. So get in a soil pit, have a look, get your hands dirty, understand that soils are so complex, and yeah, there's no better sort of learning than being sort of in the field, so to speak, but also understanding that it's working with other disciplines, so working with water quality, so hydrology teams, working with ecologists and landscape teams. So it's having that sort of general environmental awareness and that soil specific understanding. So yeah, get your hands dirty. The British Society of Soil Science offer a wide range of training courses, from basic understanding a soil profile and being able to describe it to being able to undertake agricultural land classification. So I would highly recommend those courses, particularly as we're needing more and more trained soil surveyors.
Thank you, Eleanor. Great. Did you want to add anything to that, Chris?
Just to say that in the olden days, you'd go to university and do a degree in soil science, but very few universities offer that option now. In terms of formal education, I suggest that you would look for a university department, perhaps in environmental science, that offers a soils module, and where there were members of staff who had quite good qualifications in soils. So that's what I would advise. Okay.
Amazing. Thank you, Chris. And kind of related to this, I don't know if there's any more to add in this area, but from a slightly the opposite perspective, if you are an early career soil scientist hoping to get into the field of EIA, is there any potential pathways that you would recommend in that area?
Do you want me to go first?
Yeah, that would be great. Thanks, Chris.
Okay. Unfortunately, I mean, the best way really would be to join an environmental planning consultancy. Okay, where soil inputs were valued. Read between the lines, and let me think. That my train of thought is to, unfortunately, see very few of the environmental planning consultancies employ a soil specialist full time. Okay, so, there are specialist consultancies that do major in soils and agriculture, so they would be perhaps a good starting point, but you have to look very hard to find them. There aren't that many. Alternatively, join one of the larger environmental planning consultancies that takes soils seriously, and do your very best to pick up on soils expertise. And this is something that we have concentrated on to some extent within the new IEMA guidelines, where not only do we try to set out how to do soils within EIA, but also we try to provide much of the information on soils that you would need if you were learning your subject. That's what we've tried to do. Okay.
Great, thank you. Did you want to add anything to that, Eleanor? Or do you think Chris covered it?
No, I think Chris has covered most of that.
Amazing, thank you. So changing tack slightly, the next question is, how does climate change affect soil formation, namely the topsoil and its fertility? Do you want to come in on this, Eleanor?
Yeah, I can do. So changing climate, so thinking specifically with England, the UK in mind, we're looking to see increased rainfall events, potentially changing soil wetness and soil droughtiness if we've got sort of longer, drier summers and wetter winters. So with regards to soil formation, that could have an impact on decomposition rates and the amount of soil organic matter getting incorporated into the topsoil. So that could be something that needs to be focused on. So monitoring that soil organic carbon in the topsoil to make sure that it's being maintained or increased, because as I mentioned in my slides, the soil organic matter is really important for resilience, and the more soil organic matter we have in our soils, the better they can sort of deliver their ecosystem services, as well as that carbon stock of the soil. So I'm sure there's a lot of other impacts climate change will have on soil formation and fertility. But I suppose that going back to the changing of the soil wetness and the droughtiness, that could impact the agricultural land classification grades that are assigned to a site as well.
Thank you, Eleanor. And related to this, Chris, I'll hand over to you. So the evaluations that you talked about in terms of the soil assessments, can the impact of climate change on soil health be done in these assessments? The attendee in question says they're particularly interested in how desertification impacts soil health and loss of biodiversity.
Desertification, did you say?
Yes.
Well, I would expect climate change to have quite significant effects on sandier, lighter texture soils, for example. Okay. And I would expect desertification to actually become worse, to become more extensive. This is not really, not terribly strong in this subject area, so that's really the best that I can do in answer to that question.
Great, thank you, Chris. Moving on to the next question. It sounds as if the best practice soil health methods should be applied for all projects. But are there examples of projects, permanent or temporary, that have gone wrong due to surprise soil factors? The attendees said it must be challenging to determine all soil horizons and predict all soil dynamics for large-scale projects. And I'll pose that for either of you if either of you want to come in on that.
Do you want me to have a go, Eleanor?
you can make a start, yeah.
I can have a go at it. I think the best thing to do is to refer to normal practice as I remember it. In carrying out a survey of soil resources, what you have to do is to identify the main soil textural horizons within the different soil types in your study area. And the reality is that it boils down to two types of, well, two scenarios really. There are there's the two texture horizon scenario where you have a topsoil over a different textured subsoil. And then on what is generally the better quality land, there is the three soil texture horizon scenario where you have the topsoil, the more favorable loamy upper subsoils, and then deeper down into the profile, the less favorable lower subsoils. And so the soil resource plans tend to distinguish between these two soil types. So for each of them, the point is to identify them, their distribution within the study area, and arrange for the separate stripping of the topsoils and subsoils for the less favorable soils and their separate storage. And then for the more favorable soils, the separate stripping and storage and reinstatement of the topsoils, upper subsoils and lower subsoils. That is the overall game plan. And I think it is the case that that general theory is set out in most soil handling plans for most developments. The problem arises at the delivery stage when, how shall I put it, the reinstatement or the separate stripping, storage and reinstatement doesn't necessarily happen in the way that it should. Read between the lines. Do you want to have a go, Eleanor?
Yeah, I think what you said is spot on, but it's also just highlighting that soil survey at the very start of the planning process is critical for identifying if there are any potential areas of unusual soils or contaminated soils that need to be considered alongside the sort of the natural soils that we want to retain. So at the moment, if they go out, we would recommend a soil survey at one per hectare survey density. So they're going out and across a large site, that can be quite a large survey, and that's time consuming, but it is so important because at that point you can then know what you have and avoid the problems later on in the sort of the construction program, because what you don't want is halfway through stripping your soils, you're finding something which is then having a knock-on effect, delaying construction and potentially changing what they need to do on the site.
Great, thanks, Eleanor. And in terms of those activities, in terms of the soil surveys and also the reuse of soils, is this currently regulated? And if so, who is it regulated by?
I'm sorry, can you repeat that, please, Ethne?
Yeah, so in terms of the activities that you're describing, in terms of the soil surveys and assessment, but also the reuse of soils, is this currently regulated, and who does this regulation?
Well, I think that what happens is that planning conditions are applied to planning consents. And I think generally speaking, those conditions do require the identification and conservation of the soil resources within a development site. So all of this is actually supposed to happen. But unfortunately, when it comes to the actual stripping, storage and reinstatement of soils on a site by contractors, the contractors often prove to be a law upon themselves. They do not often comply with the planning conditions And the great difficulty is that local planning authorities, or whatever you call them these days, do not actually enforce the planning conditions.
Yeah. Okay, thank you. And I think a similar thing was raised by an attendee who mentioned that formal EIAs are not always required for development. And also the current CLARE system used to allow the movement of waste soils is not always helpful. So that's a comment there from an attendee. So moving on to a slightly different vein, soil health also includes microbial activity and biodiversity. How do soil scientists increase the awareness of the importance to protect soil microbial communities to constructors and engineers? Eleanor, I'll pass to you.
Yeah, that's something we need to do, and I think it's probably the last area of soil science that is still lacking in that awareness. So we know soil sort of physics and soil chemistry pretty well, and the importance of having the sort of the good soil texture and good soil structure. But with soil biodiversity, that's critical to then facilitate the other soil functions, and it's probably the hardest topic to communicate. And I'm not an expert in soil biology by any means, but I know, like, when I'm talking to soil biologists, they are so excited about the topic because it has such an impact. So we just need to keep talking about it and trying to get people more aware. And it's trying to tie it in also with sort of the above ground biodiversity. So whenever I'm talking about biodiversity, I try and sort of highlight above and below ground. So soil isn't just a mass of mineral components, it's that mineral and sort of alive sort of mass of soil which creates a living material, really. And so, yeah, if we treated it like a live thing, maybe people would treat them a little bit more carefully. So we just need to raise the awareness more.
Thanks, Eleanor. And one for you now, Chris. This should be a quick one, but do you think there are sufficient numbers of experienced soil surveyors to meet the demands of EIA and large infrastructure projects?
In a word, no. During my time, I was the soils lead with HS2 for 7 years, and that placed a great strain on the pool of soils talent that was available. In fact, there weren't sufficient competent soil and ALC surveyors available to meet the demand. But that was an exceptional project, of course. But in general terms, no, and there aren't sufficient qualified and competent soil specialists for the needs of the planning system overall. And we desperately need universities and higher education establishments to start producing more soil scientists.
And so do you think kind of new courses as a way that we can bridge this skills gap, or is there other things that you think need to be done?
I'm not really a very academic chap, and so that's, I'm not really the person to ask that question, but I would respectfully suggest to members of the British Society of Soil Scientists that something really does have to be done about improving or increasing the number of competent soil scientists who are interested in the practical application of their subject, specifically within the planning system.
Did you have any thoughts on this, Eleanor?
I think there is a definite lack of soil surveyors, and at the moment there are a few university courses that offer modules in soil science, but it would be great if that's increased and that soil courses, degree courses, were more available across the country.
Great, thank you, Eleanor. Going back to more about the guidance that you were talking about, Chris. One attendee here says that the possible health baseline properties you listed would not be applicable for assessing every different type of soil. Does the new guidance include a procedure for selecting appropriate criteria? And have you got any thoughts about how to incorporate the gathering of this data into standard geoenvironmental or geotechnical site investigation work?
Well, the new guidelines do state quite clearly in an annex the soil information that needs to be collected when carrying out surveys for EIA purposes, and with specific reference to what is intended to do with the soils when the proposed development takes place, so that if the soils are to be used for restoration to agriculture or for ecology or landscape or whatever, then the soil properties that need to be considered are actually set out quite clearly. Okay, so there is that. But as I said in my presentation, and I'll see if I can find just bear with me a second. I said that a key point is that the guidelines are not prescriptive about these soil properties. So the guidelines tell you which soil properties to record in the field, knowing what you intend to do with the soils once the development has taken place. That's in terms of restoring the land, right? Which isn't sealed by the hard development. Okay, so then you have all of the information that you need, but the selection of the soil properties that you use in carrying out the environmental impact assessment is a matter of professional judgment based on the nature of the proposed development, the existing soil functions, and the sensitivity of the receiving environment within and around the development site. So what you have to do is, the guidelines will tell you the full range of information that you need to collect, but once you've done that, you've actually got to use your brains. Okay? Am I allowed to say that?
Yes, thank you, Chris. Great. I think we'll just have time for one more question. Sorry that we haven't been able to get through all of them. There's been loads put in here, which is great. And I can, if Chris and Eleanor are happy, pass on some of these by email so they can answer them if they're happy with that. For the final question, let me just have a quick look. So in terms of when you look at environmental impact assessments, how is the magnitude of impacts assessed? Is it still based on the area or quantity of land affected? And does it also include land outside of the development space?
Right. Well, I mean, traditionally, the magnitude was in terms of the area in hectares and the grade of the land that's affected, the grade or class of land that's affected. But the way in which the magnitude is determined of course, that relates to the soil function of biomass production for food, fiber, and timber. Okay, that's the old-fashioned approach. The way in which magnitude is calculated for the other soil functions is different, and I would refer you to the Highways England Design Manual for Roads and Bridges, sections LA 104 and LA 109, to see how it's done. And all I'm saying is that the new IEMA guidelines provide a more comprehensive approach to assessing impact magnitude and the sensitivity of the soil resource. Okay, so there was a simple way of assessing magnitude when we were just looking at agricultural land quality, but but there are no wider considerations when looking at all of the soil functions And at present, it's not completely satisfactory, but with the publication of the new guidelines, I think we're getting closer to a more comprehensive approach.
And do the guidelines address the impact of development on soils outside of the development site?
Well, I mean, this is where the manager of an environmental impact assessment has to determine the wider extent of the impacts of a proposed development beyond the red line of the site boundary. Okay, so for land and soils, it doesn't really extend too far beyond the red line, but for other subjects, for example, like landscape, obviously it extends over a much wider area, if you follow me, because of the visual assessment. So I think really that's all I'd like to say in answer to that question. Yeah.
Great, thanks, Chris. And Eleanor, did you want to add anything to anything Chris has said?
Not really, other than that it's a sort of an evolving situation at the moment, with soil health becoming more important in the consideration in EIA. Methodologies are being equally evolving, so it's something to keep your eyes open for and just to monitor what's happening, because there's so much activity in different soil related initiatives that have been happening over the past 12 months and sort of projected into the future, that there's definitely going to be a lot of activity when it comes to soil management, ensuring soil health. So it's just a great time for us soil scientists to be in this sector.
I think, Ethne, before you close the event, can I just make the point that Eleanor is a member of the AIMA working group, and she's made a very prominent contribution towards the guidelines, and she will be a named author on the guidelines. Thank you.
Excellent.
Thank you, Chris.
Well, thank you so much, Chris and Eleanor, for your really comprehensive and interesting and informative presentations. It's been really great to discuss this with you today. And I think, judging by all of the questions and interaction, all the attendees have really enjoyed it as well. And I think definitely a topic that needs to continue to be talked about, as we've discussed. So thank you so much for that. I'd also like to say a massive thank you to Sarah and Natalie from the British Society of Soil Science. To all of our attendees, I really hope you enjoyed it, and thank you to our speakers. I'll see you soon. Thank you very much.